There we go. That's better. Okay. So today we're going to see if we can finish up this chapter. So we had left off, I think we had just finished talking about why we prefer to use reinforcement rather than punishment, and sort of the pros and cons of each. And then we had, I believe, talked about shaping and chaining as two different actions that we can do. So we were then ready to move on to start talking about operant extinction and how that compares to extinction that we saw in classical conditioning. So in classical conditioning, when we looked at extinction, we were specifically looking at what happens when our conditioned stimulus is presented without that unconditioned stimulus. So what happens when you're ringing the bell and you're not giving the dog food? And so we would see that gradual drop off, I guess for you guys the graph went this way, in their behavior. So they would salivate less and less over time as we extinguished that behavior. For operant extinction, it's a little bit different. Same basic principle, because we're still having them perform their behavioral response, but instead of, say, removing our unconditioned stimulus, now we are stopping our outcome or our consequence. So if a rat is pressing a lever and getting food, then extinction would be the process of them pressing that lever and them not getting food. So we're removing that contingency. And so this is going to lead to an eventual weakening and then disappearance of the response because it's no longer being followed by the consequence that was there previously. But it's not as simple as with classical conditioning, so there are a couple of other things we want to watch out for. The first and most distinctive of these things is called an extinction burst. So instead of seeing that quick drop-off in responding, going from normal levels down to nothing fairly straightforwardly, we actually see an increase in responding at the beginning of extinction. And what's going on is actually that there's sort of an emotional outburst. So the rat has gotten used to pressing that lever to get food. So now pressing the lever and not getting food, they're getting worked up. It's no longer doing what it's supposed to do. So if you think of, say, using a vending machine and putting in money always gets you food, and then one day it takes your money but doesn't give you your food. So you're going to shake the vending machine. You're going to be angry because it's not doing what it should be doing. Same basic idea. We could call that an extinction burst. And then once we've gotten through that, once we've had that sort of aggressive responding, then we will eventually see a slowing and a stopping of our responding. And we can actually look at a graph of this. So this looks very similar to what we saw with our classical conditioning extinction, except here along the bottom we have time, but this time it's in days instead of trials. And that's just because this is from an example looking at text messaging. So this is a situation where someone was sending texts to a friend and the friend would respond fairly quickly. So during the reinforcement period, you text your friend, they text you back. During the extinction period, you send your friend a text and they don't respond. So usually people will send multiple texts. Hey, what's going on? Why haven't you responded? Then we get into that extinction burst of maybe they're angry that they haven't responded. So we'll see an increase where we have more texts being sent. And then eventually we figure out that they're not going to reply. So we slowly stop texting them and drop down to 0. And this can work with pressing a lever to get food or whatever kind of behavior we're looking at for operant conditioning. But if we see that sort of slight uptick at the beginning, that's our extinction burst, and that's what helps us tell our extinction in operant conditioning from our extinction in classical conditioning. Okay. Next, I want to give a name to something that we've been talking about but haven't explicitly titled quite yet. So I've mentioned the presence of a cue light or a warning light every once in a while. So in our operant boxes, we have a red light that will come on, and it tells our chickadees that if they made a response, they could get food. So it's ready for them to respond. That cue light could also be called a discriminative stimulus, specifically because it signals the availability of reinforcement. It's telling the birds that if they make their operant response, they will get the sort of associated consequence or outcome. So it's just something that lets us know when something is going on. And then we can have with With operant conditioning, we can also have generalization and discrimination. And this is exactly the same as what we saw with our classical conditioning examples. So I'm actually going to scroll back to those slides because the exact same graphs can apply here. Further back than I intended. There we go. So it's these two graphs, generalization and discrimination. Same exact setup for operant conditioning, except on the side here, when we were looking at our classical conditioning, we were just looking at our strength of conditional responding or conditioned responding. So this is how much is the dog salivating, or how intense of a startle response are we seeing, or whatever we were looking at. But if we wanted to turn this into an operant conditioning graph, we would just change that to amount of responding. So how much is the rat pressing the lever, or how much is the pigeon pecking on the screen? We'd still see the largest amount of responding or the most intensity over whatever stimulus they were trained to respond to, and then we would see it trail off as we got further away. And so if we talk about they're responding similarly to stimuli that are pretty close to what they were trained on, we would call that generalization, same as what we did in classical conditioning. And if we look at sort of a slightly different curve where we see a much steeper drop-off, if we focus on the fact that we'd be seeing less responding to things that aren't that original stimulus that they were supposed to respond to, then we see a much more steep curve like this, and we could say that they're discriminating. They're treating that vertical line differently than the diagonal lines. So same concept of whether we're sort of generalizing and treating them all the same, or discriminating and treating them differently. We're just sort of framing it a little bit differently. So instead of a conditioned response, we're just looking at an operant response. Same concepts. Okay, so scrolling back to where we were. All right. And then another couple of terms that might be useful that you might have, oh, yeah.
I'm going to explain again the stimulus control, please. Just the definition.
So stimulus control, like when we're talking about a discriminative stimulus, that is sort of setting the situation in which we expect reinforcement. So it's a method of stimulus control. So it's a stimulus that tells us what will happen. So that's all that is. So it's a stimulus that's, we're specifically talking about a discriminative stimulus. We're talking about something that says, if you respond now, you'll have your normal outcome. Yeah, and you can get into more complex versions of stimulus control, but I don't do that in this class. I wait for the upper level learning courses because you can get at a whole bunch of different conditional things, which get a lot more complicated. Okay, so we've been talking about things when you get something and it is reinforcing or something is bad, it might be punishing. We can call those specific stimuli or even the events themselves. We can call them reinforcers and punishers. So this mostly applies to our positive reinforcement and punishment because we are introducing a stimulus or an event that's leading to a particular outcome. But if we talk about a reinforcer, we're just saying something that follows the behavior that ends up increasing the likelihood of that behavior occurring in the future. So food is a great example of a reinforcer because if a rat gets food for pressing a lever, they're more likely to press the lever. So food is a reinforcer. And specifically, we could call food what's termed here a primary reinforcer. So kind of like when we were looking at our unconditioned and conditioned stimuli in classical conditioning, whether there was learning associated or not, same concept here. A primary reinforcer is something that we don't have to learn about. So we could call it unconditional or unconditioned. There's no learning required. Food is a good thing because food nourishes us and we need it to survive. We could also have secondary or conditional or conditioned reinforcers, and these are ones that don't directly make us happy or don't directly do good things, but that we have learned are good things. So money is a fantastic secondary reinforcer because money is a good thing because you can use it to buy primary reinforcers. So getting money is reinforcing because then you can go out and get whatever you want. So you can go out and get food if you wanted. Or if you enjoy puzzles, you go get a puzzle or whatever. So if it's something that doesn't innately have some kind of benefit to it, then it's something that we've probably learned about. We've learned that it's good, so we'd call it a secondary reinforcer. But anything that naturally makes us happier and more likely to do that behavior again, that's a primary reinforcer. And we can use these terms, sort of primary and secondary, along with punishers as well. But as I've already mentioned when we were talking about sort of reinforcement versus punishment, we almost exclusively focus on reinforcement just because it's easier to talk about. And specifically, moving forward, we're going to almost exclusively talk about positive reinforcement. So don't spend too much time worried about the punishers here. But it's just the same idea, any kind of stimulus or event that follows a behavior that then decreases the likelihood of that behavior occurring. So it could be someone shouting at you would be a punisher. So that would fit that criteria. Okay, and then our next section is to talk about schedules of reinforcement. So up until this point, we've talked a lot about, okay, the rat presses the lever and they get food. But we haven't talked about what happens if we start varying some of those relationships. So we're still, as I said, primarily focusing on reinforcement. We're going to be focusing in on our positive reinforcement. And we have already been talking about what we could call continuous reinforcement. So every single time you press the lever, you're going to receive that outcome. So every single response is reinforced. We also have situations where we use what's called either partial or intermittent reinforcement. And this is when not every single response is reinforced. So maybe sometimes when the rat presses the lever, it gets food. Other times it does not. And there are some benefits to having them not get food every single time. And we'll talk about a couple of those later on. But first, we're going to talk about what different kinds of partial or intermittent reinforcement we can have. And kind of like when we were talking about our positive and negative reinforcement and punishment, we're going to have sort of two questions that we can ask here, and then we're going to combine them into four possibilities. But our first question is it fixed or is it variable? So fixed just means that there's a predictable pattern. So you would get reinforcement after a fixed number of responses or after a fixed time interval. So we're going to stick with a rat pressing a lever to get food. So maybe every 10th time the rat presses the lever, they get a food pellet. That would be a fixed schedule of reinforcement because it's always on that 10th lever press. Or maybe we have something where after 10 minutes have elapsed, the first time they press the lever after that 10-minute time period, then the rat would get food. So they still need to make the response, but getting food or not is based on how much time has passed. Because we have that hard limit of 10 minutes, it's a fixed schedule. And then, of course, variable is when we introduce some variability. Usually we'll describe it as, on average, this is how much responding they need to do or how long they need to wait, but we're going to be talking about there being just a little bit of wiggle room to it. So usually it'll be stated as something like, after an average of 10 lever presses, plus or minus 4. And what that means is that they might get reinforcement on as early as the 6th time they press the lever. Or, by chance, they might have to wait as long as the 14th lever press. The average overall will be 10, but we have some sort of shifting, some variability in when it occurs, hence the name variable. So those are that's our first question. Fixed or variable? Is it a hard limit or is there a little bit of flexibility? Next, we're going to ask, is it ratio or is it interval? And this is basically saying, is it dealing with number of presses or is this dealing with time? So ratio is looking at number of responses. So it might be reported as a percentage. It might be reported as the 10th press or the X number of presses. So if they're talking about numbers, that's going to be ratio. And then if they talk about intervals, they're talking about time intervals. So again, it's going to be the first lever press after a certain amount of time has elapsed. So just with this question, we're asking, is it the number of lever presses that's important, or is it the amount of time that has passed? And then we can combine all of these together, and we can ask both questions together to get 4 different schedules of reinforcement. So if we start at the top, we have a fixed interval. So fixed, meaning that there's no variability. It's sort of a hard rule. Interval, meaning that we're looking at time. So the first time that they press the lever after 10 minutes have passed, that would be a fixed interval schedule of reinforcement. They would get their food when they press the lever every 10 minutes, but not before. We could then look at our fixed ratio. So same, again, a hard limit, and it's ratio, so it's the number of presses. So maybe every 10th time they press that lever, they get food. No variability there. And then on the bottom, we have variable interval. That's when we would say that, okay, about after 10 minutes, plus or minus 2 minutes, they'll get food when they press that lever. So as soon as 8 minutes, they might get food, or they might have to wait as long as 12 minutes, hence the variability. And then our variable ratio is, again, variable, but also looking at number of presses. So every 10th time they press the lever, plus or minus 2. So maybe the 8th press, or maybe the 12th press, or somewhere in between. So we can have examples of each of these. All right. And then these different patterns of reinforcement, when we get our reinforcer, can actually change our behavior. So this chart here is showing us time along the bottom. That's basically the number of trials that we're looking at. And then across the y-axis, we have the cumulative number of responses. So basically, every time that the rat presses that lever, we're going to have an increase on this axis. So if we look at our first line, that is labeled as VR. So that would be a variable ratio schedule of reinforcement. And so we see that we get a nice straight line, so a consistent slope, nothing weird going on. And we can interpret each of those little red dashes off the side. Each tick mark would be when reinforcement was delivered. So every time the rat gets food, there's a little tick mark on the side. And so because it's variable, we can see that they don't have evenly spaced tick marks. They're going to happen sort of at different levels after certain numbers of presses. So we can see them very close together, sometimes very far apart. And this variability affects our behavior. So if you think about it, the rats don't know which press is going to get them food next. So they're motivated to keep pressing that lever all the time, or as often as they can. And because getting reinforcement is tied specifically to the number of lever presses, because it's a ratio, they're going to be motivated to keep pressing that lever as much as possible. So our variable ratio schedule is going to have the steepest slope of all of our options, because the faster they press that lever, the more food they're going to get. So we see our nice straight slope, and it's a very steep slope. If we look at the one next to it, that's going to be a fixed ratio. And so you might notice that our tick marks are now showing up at pretty consistent intervals. And that means that after every, say, 10 presses, they're getting food from it. But because there's that fixed aspect here where we know that after you've gotten food, you have to press the lever 10 times before you get food again. So we actually see a drop off in responding right after they get food. That's what those little shelves are, those sort of drop offs in responding where they don't start pressing the lever again right away, because they know that if they just got food, the next time they push the lever, they're definitely not getting food. So they're going to wait a little while, and then they'll press the lever until they get food again, and then they take another break. So that step function like that is pretty indicative of our fixed ratio schedules of reinforcement. Okay, next we can get into our intervals. So variable interval looks pretty familiar. It looks a lot like our variable ratio, but this time, because it's an interval, it's centered around timing. So it's not the number of lever presses, it's the amount of time that passes. So there's a lot less motivation to press the lever as aggressively and as often as in the variable ratio version. So we see that the slope is a lot less extreme. But again, because we have that variability where they might get reinforced right after they just got reinforcement, they're going to press the lever at a pretty consistent rate. So anything variable has that nice smooth slope. We don't see any steps. We don't see any pauses. So that's going to be very indicative of those variable types of reinforcements. And then the difference in slopes tells us if it's a ratio or interval. And then our last one, this scalloped shape line, that's going to be our fixed interval. So after a certain amount of time has passed, they can get food. And we see here, we have, again, because it's based on timing, the slope isn't as steep as the others. And instead of seeing a straight step function, we actually see those little scallops. And what's going on there is probably the idea that most organisms are not great at keeping time. So even though we know that every 10 minutes they can get food, they might not remember how long it's been, or they're not very accurate at knowing exactly when 10 minutes has passed. So when they've received food, they know that they just got food, so they shouldn't be pressing the lever because they're not going to get food right away. But as more time goes on, it's getting a little bit fuzzier of how long it's actually been. That's why we see that gradual ramp up. So they'll start checking it after a little while. And then as we get closer to those 10 minutes, then we're going to see more pressing until they finally get food, and then they're going to stop again. So that's why we see that gradual curve, mostly because organisms are not great at keeping time. But that gives us a nice distinctive pattern to look for if we were shown sort of any of these types of slopes. And if I was asking you to differentiate between them, I don't like using images on tests, but if I were describing something, I would be sure to give you enough information to tell apart, say, our variable ratio and variable interval. I'd probably talk about the steepness of the slopes, so you'd have to have a comparison. But if we talk about sort of that step pattern or that scallop pattern, that's a pretty clear indicator of, are we talking about fixed ratio or fixed interval? So we have ways of keeping them distinctive. Okay, and so we've got to this point, and we always want to ask, well, what of those 4 options is the best? And technically, we can ask what of our 5 options is the best, because we could still be thinking about our continuous reinforcement. Though, as I guess a technicality, we could call continuous reinforcement a fixed ratio schedule of reinforcement where it's every 1 lever press gets reinforced. So you could technically fit that one under our fixed ratio responding. But as always, our answer to which is the best is that it depends on the situation. If you're trying to have someone learn something very, very quickly, a continuous reinforcement schedule is going to be your best bet. And that's because every time they perform that response, they're going to receive reinforcement. So it's really easy to see that direct connection between the action and the outcome. So if they press the lever and get food every single time, they figure out very quickly that the lever leads to food. That leads to that easier to perceive those consequences, but it also causes some issues. If every single time you press the lever, you get food, as soon as you begin extinction, as soon as you don't get food for pressing that lever, we know right away that it's extinction because that's never happened before. So we would see an extinction burst very, very rapidly with continuous reinforcement. And then we'd see a pretty quick drop off in their responding after that extinction burst because it's not doing what it's supposed to, and we know right away that it's happened. In contrast, if we use any of our partial or intermittent reinforcement schedules, it's pretty normal to have a single lever press not reinforced. It's going to take us longer to learn that association between pressing the lever and getting food, but we're going to be a lot more resilient when extinction happens. We're going to persist for a longer time because, hey, it sometimes happens where we don't get food when we press the lever. So if we're concerned about the longevity of a response, if we want it to keep happening, even if we're not around to reinforce it, one of our partial or intermittent reinforcement schedules is better. And specifically, any of our variable patterns are going to be the most effective because that's even more uncertainty. And so we can actually see this illustrated along the bottom, where continuous reinforcement would be sort of solid green. Every single time you always get reinforcement, you always get food. Intermittent is sometimes there's food, sometimes there's not. And it's kind of a blurry transition between, well, is it just intermittent or is it extinction? And we don't know if it's extinction because we might get reinforcement in the future. So we kind of have that blurry line, and that's why our partial or intermittent reinforcement tends to last longer. And for the most effective, especially if we're looking at beating extinction, would be our variable ratio pattern of responding. That one, for whatever reason, is the most resilient in terms of extinction. So you can pick and choose which works best for your particular scenario. In our lab, when I talk about our chickadee research on Friday, I'll mention the fact that we actually use a combination of both. We start off with continuous reinforcement because it means faster learning, and then we gradually transition them over to partial reinforcement, where they don't get food every single time because we don't want them to stop responding. So we use a little bit of both in order to get what we want out of a situation. So I'll talk about that a little bit more on Friday. But that is the end of our operant conditioning section. So I'm going to take a moment here and actually talk about how do we tell the difference between classical conditioning and operant conditioning, because they seem fairly similar on the surface. So what are some things that we can look for to tell the difference? I also have a link to a YouTube video if you wanted to go and watch that, and it's just someone walking you through the two different kinds of conditioning and some differences between them, but we can do it verbally here as well. So first off, we can look at the controlling stimulus. What is it that's triggering this response? So in our Pavlovian or classical conditioning, our conditional stimulus is what's producing our conditional response, or our conditioned stimulus is producing our conditioned response. That's the thing that we've learned about, and that's what's running the behavior we're interested in. In operant conditioning, we're going to start with our discriminative stimulus, that antecedent, the thing that starts at the beginning that tells us if we produce a behavior now, or if we make a response now, a particular outcome will follow. So we have sort of different focuses on what starts off everything. For our learned behavior, for classical conditioning, we're focusing on something that is elicited, something that is involuntary. A dog doesn't choose to salivate. It happens automatically when they're exposed to food. So when they learn a conditioned response, then they're going to be producing that response without intentional action. So it's something that they're doing automatically. So it's involuntary. And then in contrast with operant conditioning, we switch from using elicited to something that is evoked, because it is a sort of a voluntary response. It is an action that the animal is taking. So a dog doesn't choose to salivate, but a rat is going to choose to press a button. So that's why it's voluntary, because there is some kind of action being done with intention. Though intention is another one of those gray areas that some people don't like when using non-human animals, but when we look at our important stimulus, what's our starting point? What gets us moving? So our unconditioned stimulus, that food that we started with in our Pavlovian or classical conditioning, that's what's the important part here. So we couldn't learn anything with our conditioned stimulus unless we paired it with our unconditioned stimulus. So that's what's important. That's what's there to be learned about. But for operant operant conditioning, our outcome, our consequence, whether it's a reinforcer or punisher, that's the thing that's important in what we learn. So we're going to change our behavior based on that outcome, whether it's good or bad. We can ask the question, does the behavior change the likelihood of the consequence? In Pavlovian conditioning, we're not looking at likelihood of a behavior leading to a particular consequence. That's something that we've focused only in our operant conditioning. So that's that law of effect kind of concept. So if we mention behavior changing likelihood of consequences, then we're really focusing in on operant because that's the only place we've mentioned it. We can ask what is being learned. In our classical conditioning, we were forming a link between our conditioned stimulus and our unconditioned stimulus. We linked the bell with our food. But in operant conditioning, we have that antecedent behavior consequence or stimulus response outcome, that sort of trio of things coming together. So we have slightly different patterns that are important here. And then the last question is, can it add a new response to your repertoire? So with our classical conditioning, we started with food makes a dog salivate. That's unconditioned. That just happens. The new thing that we're doing is having the dog salivate to something else. So it's the same behavior, just in a new situation. So we're not actually adding a new behavioral response. We're not adding a new behavior. It's the same old behavior, just to something else. But in operant conditioning, we are going to be adding some kind of new response. So we're getting them to press a lever or peck a screen or whatever. So it's not that we're co-opting an existing thing, we're getting them to do a different response in order to get their reinforcement. So these are a bunch of different questions that you can look at when evaluating a situation if you're trying to decide, okay, is it Pavlovian or is it classical or is it our operant conditioning? What's going on? So this is a pretty handy chart to take a look at. All right. Any questions about classical and operant conditioning before we move on? Not quite yet. If you come up with more, we can have that chat later. You can always send me an email about it. But for the last part, I want to talk about social learning. So this is when we start learning about actions, not just from sort of interacting with our environment, but with some kind of cognitive impact as well. So you've noticed that most of our other procedures have either completely gone against cognitive involvement with our behaviorists, and especially with Skinner, our radical behaviorist. But we do want to introduce, what about cognitive function? What about mentality? What about making a decision? So this is when we're starting to reintroduce cognitive psychology. And we're going to start by talking about Tolman. So this is our big name for cognitive psych here. And they said that explanations for behavior should include more than just our environmental stimuli. And it should be more than just publicly observable behavior. So when we've looked at operant conditioning, we've been looking at, okay, they press a lever in response to a stimulus in their environment, stuff that we can overtly observe. But Tolman wanted us to start focusing in on other stuff. What's going on internally? What kind of mental processes are involved? What part of learning is going on that we can't physically see? And so this was focused in on sort of two big concepts. The first of these is the idea of latent learning. And this is when you learn a behavior, but we don't have an opportunity to see it until that situation arises. So most of this latent learning was discussed, or I guess studied, using cognitive maps. So they would have rats who'd run in mazes, kind of like this one here. And so some rats would be put in the maze and there's no food anywhere. They would just be allowed to wander through the maze. There's no reason for them to try and get from the start to the end. They're just exploring. There's nothing there. None of the tunnels are particularly important. No route is particularly essential. But by wandering around, by having experience with that environment, they proposed that these rats were forming cognitive maps. They were forming sort of these mental representations in their mind of their environment. And so by having that experience, they learned something, But we didn't see any change in performance because there was nothing to perform. There was nothing for them to be doing except wandering a maze. But as soon as we introduce the opportunity for reinforcement, if we put a pile of food at the exit, all of a sudden those rats would be motivated to perform. And we could say that if they were forming these cognitive maps, then their previous experience of wandering around that maze should actually allow them to solve it faster. They should get out faster than other rats who didn't have that prior experience, which in almost all cases they do show. So there is evidence for that latent learning where they've learned it, but they don't show it off until there's the reinforcement available, until there's motivation to perform in a particular way. And it's probably based on some kind of mental representation of their environment. So we get some evidence for our cognitive maps. It's the same as if you move to a new neighborhood and you want to go for walks. You sort of wander your new neighborhood. You don't have anywhere that you specifically want to go, but you want to get out of the house. And then after a while, maybe you then have to go and find a grocery store. And so somebody tells you that it's near this other thing or it's on this particular street. And from having wandered your neighborhood, you go, oh yeah, no, I know exactly where that is. I'll go straight to it. So you don't have to wander aimlessly. You don't have to look it up. You just know where to go, because even though it wasn't important at the time, you were almost passively learning information about your environment. So that's the process here of latent learning, specifically using our cognitive maps. So we can also talk about Bandura, and this is interesting. So Albert Bandura was actually a resident of Alberta, which is nice and easy to remember due to his first name. But he was important for observational learning, or specifically social learning. And most of his work was done by watching kindergarten students. So he proposed the idea that we could understand what to do by watching others do things. So we could learn by seeing somebody else go through a process. So we're almost like we're learning vicariously. We're living through them, we're learning through them. And so he even called this vicarious conditioning. So it's when an organism, when you are watching another organism, which we can call a model, go through a learning process. So we could have a rat. So we have a model rat, and they're being conditioned. They learn that pressing the lever gets food. If we have an observer rat that watches our model learn that process, when that observer is given the opportunity to interact with a lever, they're going to push it a lot faster than someone with no experience. So they've learned something by watching the other rat learn. So that's some evidence for vicarious conditioning. And this kind of makes sense, because if we think of a lot of the stuff that we do, we behave in particular ways because we've observed others behave in particular ways. We do have some either classical or even operant conditioning. Maybe our parents tell us what we should be doing, or maybe we've formed associations between existing stimuli, but there's also a lot of cognitive processes going on. If you think about going to a new country or even coming to a new school, my first day on campus, I wasn't quite sure where to go because I had never been here before. So I waited for a minute and I watched the crowds. I followed someone else to the main entrance, and from there I figured out how to get into the buildings. So I employed this observational or social learning, and it's something that we do fairly easily and fairly regularly as well. But we can break down this process into 4 different phases. So the first part is attention, where you're watching, the learner watches the trainer. We also have to look at retention. So when the trainer models the response and the learner thinks about the response. So here, when they're talking about trainer, I think they're referring to the model, a couple of different terms, of course. So if we had our observer rat watching our model rat learning how to interact with something, attention is just, is the observer paying attention? Are they watching? Retention is then the observer, or the observer has to be watching what the model is doing, and they should think about what they're doing. So there's some assumed cognitive process. This is one of those steps that anyone in, say, behavioral psychology or one of those behavioral perspectives would have issue with, because we imply thinking. Next, we would have production. So this is when our learner, our observer, is going to demonstrate the response without having that model present. So we give that observer rat the chance to interact with that particular, say, lever, whatever's in the environment. And then we have the motivation stage where, okay, the rat pressed the lever and they get food too, just like the model did. So that's going to motivate them because it's providing reinforcement. So they see that it leads to something good, so now they're even more likely to do that behavior in the future. So it's almost like we've gotten a head start on getting them to perform a particular response by assuming some kind of observation and retention and then copying mechanism. And we actually have some neurological evidence for this kind of behavior. So this idea that we are set up to watch for and then imitate different kinds of actions. So you might have heard of mirror neurons. And these are neurons that are activated by performing an action or by seeing another perform that same action. So these are more on the recent end of things that we've discovered, and they're mostly studied, at least most of the literature I've seen have looked at them in monkeys, just so that we can try and compare them to humans. There isn't too much about human mirror neurons quite yet. But the idea is the same part of your brain will light up when you watch someone else do an action as when you do it yourself. So watching someone else do something makes you sort of imagine yourself doing it too. And these mirror neurons are what we're monitoring to sort of figure that out. A more complex example would be maybe watching someone ride a bike makes you react as though you are riding a bike. Your brain imagines what it would feel like to ride a bike. Mostly, if we're looking at single neurons, it's going to be something a lot more simple than that. It might just be eating or moving in a particular way or something like that. But that's the basic idea for those, which is pretty cool. All right, and of course, we can't talk about social learning without talking about one of our classical learning studies, specifically a observational learning study. So you might have heard of the Bobo studies. This is something that I always thought was very, very weird when it was first explained. But basically, they had a situation where they had these Bobo dolls. I don't know if you've ever seen them. When I was younger, we called them Weebles, and they would say Weebles would wobble, but they won't fall down because they're heavily weighted on the bottom and they'll sort of swing back and forth, but they'll always right themselves because they're heavy on the bottom. So they had a giant one and it was inflated, so it has a very low center of mass, so it doesn't fall down, and it was creepily designed to look like a clown, which, you know, just to give everyone involved nightmares. But they set it up so that they had a bunch of children who would one at a time observe adults interacting with these dolls. So they would have the adults interact sort of either positively or negatively. And here we can focus in on aggressive interactions because that's where the coolest results come from. But if the children watched an adult walk into the room and say, punch the doll, they would start their minds would start turning of like, ooh, is that how we're supposed to interact with that? And especially if we introduce either positive or positive reinforcement or positive punishment in terms of someone saying, good job, or yeah, do that again, or someone saying, you shouldn't do that, that's bad, we'd actually see the children's behavior adjust accordingly. So if an adult was aggressive with the doll and they were reinforced for it, if they were told good job, then the children would be much more likely, when given the opportunity to interact with that doll, to hit it themselves. Whereas if they saw an adult interact with it and hit it, and then they were scolded, the children were less likely to hit it themselves because they didn't want to get scolded too. But this gives us evidence that the children were copying the adult's behavior. And you can actually see in some of these images, these kids were like really into hitting this doll. They were very aggressive and they got full, massive full body responses. So it's a really interesting study to look into. I'm sure there are a couple of maybe BBC productions on YouTube you could look into if you're curious. All right. Okay. And I only have, I believe, 2 slides left, so I'm going to try and run through these really quickly. The first is to mention that concept of biological preparedness again. And we already kind of talked about this earlier when I mentioned that it's easier to learn different things about different kinds of stimuli. So I mentioned that it's easier to condition a startle response or a fear response to something like snakes and spiders. And it's a lot harder to condition that to, say, neutral stimuli like flowers. So we are set up or prepared to learn certain types of associations with certain types of stimuli. So we have that biological basis for those. We also saw that we tend to associate things that cause nausea with things that we eat or taste. And then physical pain would be associated with physical stimuli. So we have a bunch of setups that sort of predispose us to that. So just sort of reminding us about that. And it isn't just for classical conditioning. This can be for operant conditioning as well. There's a really interesting example where someone was trying to use classical conditioning on raccoons. They wanted to use raccoons in a commercial, and they wanted the raccoons to have 2 coins and drop them in a piggy bank. But they were reinforcing the raccoons with food. And what raccoons tend to do with food is rub it together. So they formed an association between the coins and food, and before too long, the raccoons are sitting there rubbing their coins together and they can't bear to let them go. So it's very difficult to condition certain behaviors, especially when they're linked with different kinds of outcomes. So something we have to watch for when conditioning different situations. And we have one other thing, which is this concept of learned helplessness. So if we go back to our idea of sort of escape and avoidance conditioning, we can learn to escape from bad situations. You have a headache, you take Advil, then it's not a big deal. If we have this situation of learned helplessness, sometimes you experience an aversive situation and there's no way to escape it. You learn that it's not worth trying to escape anymore. So if you get headaches and you take Advil for it and it doesn't make the headache go away, then you're not going to take Advil again. Even if it was some weird fluke, maybe your head was hurting for a reason that Advil wouldn't help. But it could lead you to then avoiding doing behaviors that might help in the future, even if Advil would have helped. So they've looked at this in a lot of different situations, but they had dogs that were exposed to a shock where some of them could be exposed to the shock and they'd head to the other end of the chamber and they'd get away from it. Some dogs were forced to endure the shock so that they couldn't escape. And then even after that, once they learned they couldn't escape, even if you opened up the chamber and they could go elsewhere, they chose not to. So they learned to be helpless. So they learned that, well, we can't control it, so why bother? And this is something that's fairly important when it comes to things like depression, because we can learn that, trying to do something no longer does anything for us. The outcome doesn't happen. We don't sort of escape the situation, so we stop trying. And there are a lot of interesting approaches to sort of overcome that. But that is a good spot to leave us here. I did manage to finish this chapter. So next time in class, I will be talking about just operant conditioning in chickadees. So it's not going to be new content. It's just going to be a practical application. So if that's something you're interested in, we'll chat about that on Friday. And then also have some time to answer questions if you have any.